Here is today's starting frame from Tiasik Taluong in Rayong, Thailand. At first glance, it looks quiet, a compact core sitting in the middle of a fairly clean field, no dramatic flaring, no obvious fragmentation, just a steady central brightness, surrounded by a faint glow. But look closer, the shape of the coma isn't perfectly round. There's a slight stretch toward the lower right, and that's the first hint that something directional is happening here. Even in the raw grayscale capture, the symmetry is slipping. This is where today's update really begins. Once we switch into the enhanced color scale view, the story changes. Fast, that small stretch we saw in the grayscale now pops into full clarity. The inner coma isn't glowing evenly. It's shifted. Notice how the brightest region isn't perfectly centered. It's pushed slightly toward one side and the opposite side falls off more gently. That kind of offset isn't noise. It's the signature of directed activity. Something is leaving the object faster in one direction than the other. You also start to see a faint plume forming, barely lifting away from the core. This is the earliest hint of the clear jet that becomes unmistakable. Later in today's data, this enhancement confirms the object isn't just brightening or fading, it's shaping itself. Here's where things get interesting. In this high-contrast grayscale frame, the object's core shows a subtle but undeniable directionality. The coma isn't a smooth circular cloud like you'd expect from a quiet interstellar visitor. Instead, the brightness stretches outward in a single consistent direction. The same direction hinted at in the earlier frames. What this really means is simple. The activity isn't symmetrical anymore. That dark central region with a softened halo is being pulled almost nudged toward the same vector we saw before. And because this view removes the color data and focuses purely on intensity, it confirms that the shape isn't an artifact of processing. It's baked into the signal itself. If the earlier frames were suggestions, this one is a statement. 3. Atlas is pushing material outward in a focused direction, not in a random cloud. Now, this one leaves no room for debate. Once you apply the Larsenina rotational gradient filter, the structure around 3I Atlas snaps into focus, and suddenly the jet becomes the dominant feature in the entire frame. Look closely at the center. You can see a bright neat light stream shooting out in one direction paired with a fainter counterbeam on the opposite side. That's classic jet behavior. The kind you expect from an actively rotating nucleus that's venting material through specific openings, not from a smooth, uniform coma. Here's the thing. This isn't a glitch, and it isn't noise. The shape is consistent with the angle of solar illumination, and it lines up perfectly with the anisotropy hinted at in the previous 3 images. The rotational processing just makes the invisible obvious. And when the feature survives filters this aggressive, it means one thing. The jet is real, coherent, and sustained, not a momentary puff of dust. This is the clearest confirmation yet that 3 Atlas isn't behaving like a passive interstellar visitor. It's actively shaping its own environment. Here's where everything comes together. This composite frame shows for different processing styles: raw, high contrast, inverted grayscale, and full rotational gradient, and the surprising part is how perfectly they line up. Start in the top left. The unenhanced view already hints at a directional brightening. Top right. Once you boost the intensity profile, the bright core stretches into a subtle plume. Bottom left. Inverted, and the same plume shows up again. Darker on one side, lighter on the other. Bottom right. The Larsen-Secondina filter doesn't just confirm it. It exposes a clean structured jet flowing outward with a defined angle and a surprisingly stable shape. What this really means is that the feature isn't an artifact of processing. It survives raw stacking, contrast boosts, inversion, and rotational filtering. For independent looks, one consistent result, you're seeing directional outgassing. A true jet locked onto one side of 3I Atlas, and considering this object's interstellar origin, that's a big deal. It suggests there's an active evolving mechanism driving the release, not a simple fading cloud drifting through space. This is the kind of consistency astronomers look for when they say, yeah, that's not noise, that's physics. Now, here's a completely different look. And honestly, it's gorgeous. This is Daniel's final stacked image processed by Duncan Pond from Dwarf Vision. And unlike the grayscale frames from Thailand, this one brings color into the mix, and that changes everything. Right away, your eyes go to the green core. Classic emission from diatomic carbon or C2, the stuff that gives many comets their eerie glow. But look closer. That soft triangular extension coming off the nucleus, that's the same jet direction we've been tracking in all the enhanced images. But here it shows up naturally without any filters, without any tricks. You're seeing real structure in real sky color. The tail doesn't flare out like a normal dust plume. It forms a clean, narrow wedge pointing away from the sun, almost like the object is firing material in a controlled direction. Seeing this feature appear in both scientific enhancements and natural color astrophotography is a big confirmation. It means the jet isn't just technically detectable. It's bright enough and stable enough to show up to the naked eye in long exposures. And that's rare for an interstellar visitor. Now, let's zoom way out far beyond our solar system. While we're watching an interstellar visitor show off a brand new jet, JWST just captured this masterpiece to dwarf galaxies locked in a slow cosmic collision. And here's why this matters to our story. These galaxies, NGC 4490 and NGC 4485, are basically a time machine. They have low metal content, chaotic star-forming regions, and turbulent gas streams. The same kind of environment objects like 3I Atlas may have formed in before being thrown into interstellar space. Look at the image. The red filaments are dust and gas being stretched like taffy. The bright blue knots are fresh, star-forming hot spots. That long connecting bridge, that's material ripped out during their gravitational encounter. This is the kind of environment where strange objects are born, worlds, fragments, and icy bodies that later get kicked out into the void. So, while 3I Atlas is showing us a clean directional jet right now, JWST is showing us the kind of birthplace where such behavior might actually make sense. It's a reminder that interstellar visitors don't come from quiet neighborhoods. They come from places where gravity, turbulence, and collision shape everything. Sometimes in ways we're only just beginning to understand. If 3I Atlas looks unusual, maybe that's because the galaxy it came from was unusual, too. So, here's where we're left today. 3I Atlas didn't just brighten, it didn't just stretch. It revealed a clear structured jet pointing in a stable direction. And when you line that up with the environment interstellar objects come from, the chaotic, violent dwarf galaxy worlds JWST just showed us, the story gets a lot more interesting. Now, I want to hear from you. Do you think this new jet is just normal activity from an interstellar traveler? Or are we watching something that doesn't quite fit the usual playbook? Drop your thoughts in the comments. I read every single one. And if you're following 3I Atlas day by day like I am, hit like, subscribe, and tap the bell. We're tracking this thing in real time. And the next update could be even stranger than today's.